Hello and welcome to this session on statistics. In this session, we are going to discuss about covariance and correlation. Covariance and correlation are two of the most important measures in statistics, using which we can understand the relationship among multiple variables. Now these are basically used for bivariate measurements. That is like when we have two variables, we can measure the relationship among those two variables using this covariance and correlation in statistics. Now let's see what is covariance. So covariance is a measure of the joint variability among two random variables. Now here suppose we have two variable, one variable is x, the other variable is y. So to understand how these two variables are varying from one another, how they are different from one another, so in those kind of scenario we can use this covariance measure in statistics. So covariance can take any value between minus infinity to plus infinity. So here the result will be within minus infinity to plus infinity. So if we get a negative value from the covariance measure, that will indicate that there is a negative relationship between the variables. If we get a positive value, it represents there is a positive relationship, and when the value is 0, it indicates that there is no relationship among the variables. So when we change the unit of observation on any or both of the variables, then there is no change in the strength of the relationship between two variables, but the value of the covariance is changed. Now when we are changing the units of variables, suppose both the variables are in grams, both the variables are in a unit gram. Now here, like when we check the covariance, we'll get the strength of the relationship, which is with respect to grams. But suppose for one variable we change the unit to kilogram. Okay, one variable is gram and the other variable is kilogram. Now both the variables have different units. In those kind of scenario, covariance value will also change. When we are changing the units, covariance values also will change. So covariance gets affected by this unit. So now to look into the types of covariance, like when we have multiple variables like two variables x and y, so there can be a positive covariance. Positive covariance means our covariance value will be positive. In that scenario, we can say like when x is increasing, y is also increasing. So in this scenario, we can see here when x is increasing, x values are increasing, y values are also increasing. So this will be a positive covariance. Negative will be like when x is increasing, y is decreasing. So like when x is increasing, y is decreasing, then that will be a negative covariance. And like we can have zero covariance if there is no relationship among the data. So how do we find this covariance? So consider two numeric attributes a and b. Suppose we have two variables a and b. Both are quantitative in nature. So both are numerical variable. And we have a set of n observations. So we have total n number of values there, n number of elements there, starting from like a1, b1 till an and bn. So the mean value of a and b respectively are also known as expected value. So here in covariance, like we can call the mean value as the expected value. So first suppose we find the expected value of a, which is nothing but the mean value of a. So mean value of a will be given as summation of a divided by n. Similarly, mean value of b will be summation of b divided by n. So we'll get the mean value. Then we can find out the covariance by using this formula, that is expected value of a minus a mean and then b minus b mean. Or we can also take it as summation of a minus a mean into b minus b mean divided by n. So this is the formula for population covariance. So we can find out the covariance among population data by using this particular formula, that is a minus summation of a minus a mean into b minus b mean divided by n. So here covariance, we can write it as COV of A and B can also be found as expected value of A and B minus A mean and B mean. This is also fine. Like we can also use this formula to find out the covariance. So if we get the covariance value greater than 0, that means both A and B tend to be larger than their expected value. If we get a negative covariance, so if A is larger, then its expected value B is likely to be smaller. So like it's like a negative correlation. So when we have negative covariance within the data, that means one variable is larger, that is A is larger than its expected value, but B is likely to be smaller than its expected value. And we can say two of the variables are independent if the covariance value is 0. So now these are the formulas which is there behind covariance, that is summation of like suppose we have two variables x and y. So population covariance formula will be summation of x minus x mean into y minus y mean divided by n, and sample covariance formula will be summation of x minus x mean into y minus y mean divided by n minus 1. So this is the covariance. Now here covariance, we are checking the variability among two variables x and y. So this is the formula we are using. Now, if we take covariance of x with x, if we take the same variable and we try to check the variance, then that is nothing but the variance itself. So it will be summation of x minus x mean whole square divided by n minus 1. So covariance of the value like a single variable is nothing but the variance, and covariance of multiple variables, that is like two variables, is of this formula, that is summation of x minus x mean into y minus y mean divided by n minus 1. So this is the formula for finding out the covariance. We can also use this formula, that is expected value of A and B minus A mean minus B mean. So we can use either of this to find out the covariance. Now here, like to take an example, there is this table which shows the stock price of two companies. Now within this table we have stock price of two companies. One company is all electronics and the other company is high tech. Now there is given some time point, like time point is nothing but we can say okay, like month wise. So suppose these values are in dollars. So suppose for month 1, all electronic stock price was $6 and high tech stock price was $20. Then month 2, all electronic stock price dropped to $5 and high tech dropped to $10. In month 3, all electronics stock price dropped to $4 and high tech dropped to $14, like that. So now this table shows the stock price of all electronics and high tech. So suppose if the stocks are affected by the same industry trends, will their price rise or fall together? Now these two are similar kind of companies, both are like electronic companies, and the stock price can be affected by the same industry trend. As they are into same industry, their stock price can be affected by the same industry trend. So we have to find out like if it is going to rise or fall together. So in this kind of scenario, we have to see how all electronics and high tech stock price are related. So is it like when all electronics price is increasing, high tech price is also increasing, or is it like when all electronics price is decreasing, high tech price is also decreasing? So like that, we just have to find out how they are related with one another. So now for that, we can find out the covariance of all electronics and high tech. Suppose all electronics is X, high tech is Y. So we have to find out covariance among both of these. So now here we are finding out the covariance. Like here first we have taken the expected value here. That is nothing but the mean of all electronics stock price, then the mean of high tech stock price. Then we are finding out by taking the summation of uh, that is expected value of X and Y, that is x into y, that is first value with the second value, like that we have to take the summation of that. So once we have taken the summation, then we are doing here minus of x mean into y mean. So we are using this formula basically here, that is expected value of a into b minus a mean and b mean. So that same formula here we have used, and within this what we are getting is we are getting the value as 7. So covariance value is 7. So we can either use this formula, that is like E of a b minus a mean and b mean, or you can also use this population covariance formula. So here within this we are getting the value as 7. So now we are getting a positive value here. So we are getting a positive value of covariance here. So as the given value is positive, we can say that stock prices for both the companies rise together. So when stock price of all electronic is rising, high tech stock price is also rising. Okay, so they have a linear relationship, a positive linear relationship here. So this is how like we can measure the covariance among the data. So now next one is correlation. So correlation is a statistical technique that describes whether and how strongly two or more variables are related. So it will tell you how strongly they are related. So is it like 90% related? Is it like 80% related, like that? So here we can also see the strength of the relationship. In the previous one, like covariance, it just shows us the direction of the relationship. So is it like going towards positive direction or negative direction, and the value will be within infinity. But in correlation, we can also check the strength of the relationship. That is like the direction as well as the strength. That is like if they are like how much positivity is there, okay, out of 100%, like that. So correlation analysis helps to understand the direction and degree of association between variables, and it suggests whether one variable can be used to predict another also. Like here, suppose we know the stock price of company A, can we predict the stock price of company B? Okay, so that also we can find out here. And also it tells us the direction, that is if it is positive linear or negative linear or no non-linear, and degree of the association, that is like how much positive or how much negative, that also we can get here in correlation. So correlation value will be between -1 to +1. It will always be within this range. So it will be within 0 to +1, that is 0 or 0.95, that means 95% it is linearly related. So the degree of association is 95, like that. So it's positive, or we can get in negative value. So correlation can take any value between -1 to +1, wherein values close to +1 represent strong positive correlation, and values close to -1 is an indicator of strong negative correlation. And if the value is 0, that means there is no correlation among the variables. Now here to measure this correlation, there are multiple measures which are there. One of the most famous measure which is used is Pearson's correlation coefficient. This is one of the very important measure to check correlation among variables. So Pearson's correlation coefficient is the most popular measure of correlation between two variables. It measures the linear relationship among two variables. So here we can measure the linear relationship among two variables. It is also denoted by a small r. It is also denoted by small r. So we can also say like P of x and y, that is Pearson's correlation coefficient of x and y, is nothing but covariance of x and y divided by standard deviation of x and y. So here in Pearson's correlation coefficient, we just divide the covariance of the data by standard deviation. So what this will do is, this will just negate the units. Okay, when we divide any value by standard deviation, it just removes the unit. So this particular measure, correlation coefficient measure, is unitless. So this is a unitless measure. So suppose we have one variable in kg, that is kilogram, the other value other variable is in gram, then here it will not matter, like there is no problem in that. Like if we take both the variables, it will give us the proper relationship among them, because this measure is unitless. As we are dividing the data by standard deviation, what is happening is like it is removing the unit, so it's just checking for the variance within the data, how variable is the data from the average, like that. So here covariance of x and y divided by standard deviation of x and y is the formula for correlation coefficient. So we can say E of x minus mu of x, that is mean of x, then y minus mean of y divided by standard deviation of x into standard deviation of y. So this is the formula to find out the correlation coefficient, that is Pearson's correlation coefficient. So here we just find out the covariance, then we can divide the data by standard deviation of both the values. So now when we get the correlation values, those will always be within +1 to -1. So now if we are getting a positive 1 value, that is like if the R value or the Pearson's correlation coefficient value is 1, that means there is a perfect positive correlation among x and y. So suppose we have in x-axis x value and in y-axis y variable or y value. So here if we are getting 1, means they are strongly correlated. in a linear way. So perfect positive linear correlation is there. And 0.9 means like high positive correlation, 0.5 means it's low positive correlation, and 0 means there is no correlation. So we can see within the data here like x and y, we don't see any kind of linear relationship within x and y. So here like we'll be getting r value as 0. And then here we can see low negative correlation, that is minus 0.5, then high negative correlation minus 0.9, and perfect negative correlation, that is minus 1. That means when x is increasing, y is decreasing here. In the first case, x is increasing, y is also increasing, but in the last case, when x is increasing, y is decreasing. So this is what we are getting here. Now the key difference between the correlation and covariance, what is the key difference between them? First is like meaning wise, covariance is a measure indicating the extent to which two random variables change in tandem. So now it just measures the correlation itself. So it just tells, okay, like how two random variables are changing and to what extent they are changing. And correlation is a statistical measure that indicates how strongly two variables are related. So it can tell us how strongly they are related. Like within a scale of -1 to +1, we can get the relationship strength also here. So here in covariance, it just gives us the direction to what extent they are related. But in correlation, we can also measure the direction as well as the strength of the data. So here key difference, what is it is like this is covariance is measure of correlation, but correlation is a scaled version of covariance. So it is just a scaled version. So we have some scale that is -1 to +1 within this. So values in covariance will lie between -infinity to +infinity, and correlation values will lie between -1 to +1. And change in scale, like when we change the scale value, it is going to affect covariance, but it is not going to affect the correlation. So scale change in scale will not affect the correlation. Also, if you look at unit free measure, covariance is not a unit free measure. So if we have different units, all the variables are of different units which are related in some way, that is like gram and kilogram like that, then it is going to affect covariance a lot. So covariance is not a unit free measure, while correlation is a unit free measure. So now to summarize, correlation is a special case of covariance which can be obtained when the data is standardized. And now when it comes to making a choice, which is better measure of the relationship between two variables, correlation is preferred over covariance because it remains unaffected by the change in location and scale, and can also be used to make a comparison between two pairs of variables. Now correlation is termed as a better measure because here we can also check the strength and it gets unaffected by the unit. It is a unitless measure, and here we can easily compare to what extent two variables are related, that is yeah, how strongly they are related. Is it like 90% or 80%? So we can find out the strongness, the degree of association also within correlation. So it is a special case of covariance which can be obtained when data is standardized. So here basically when we are dividing the data by standard deviation, we are just standardizing the data in this case. So it's a special case of covariance where we are just obtaining the relationship by standardizing. Okay, so this is just about covariance and correlation. So now here what we will do is like we will check this out uh, in Python. We'll see how do we measure covariance or correlation among multiple variables in Python programming language. So we'll take this same example and we'll find out both covariance as well as correlation for this data. So correlation is nothing but covariance divided by standard deviation. So we will check that out and we'll also check covariance. So here we'll take the same data for this. So let me open up Jupyter Notebook. So here we will name it as covariance and correlation. So we have to find out covariance and correlation. So here first thing is we'll import NumPy. We can find out covariance. We can measure covariance using NumPy, as well as we can use you can use pandas. So now these two packages we'll be using here. So first to take the data, so here I will create the data. Like we'll be taking the same data, that is time point, all electronics high tech, and 5 values are there, T1 to T5. So here I will take the same thing. So we have 5 time frames here, that is T1, T2, T3, T4 and T5. And the values what we have in all electronics and high tech, let us take those values. So here I'm just creating a dictionary, 65432 and 2010 1455. So now we have taken the data. So this is our data, which is in which is right now in dictionary format. We'll just convert it to data frame format so that we can use pandas for calculation. So we'll just convert it to data frame in a tabular format. So we'll pass this data and convert it to data frame. So now we'll just print the data frame. So this is how the data is, that is time points T1, T2, T3, T4, T5, and here the values which are there is all electronics and high tech. These are the two companies and these are the stock prices which is in dollars. Now here, like first we'll plot it in a scatter plot. Scatter plot can also show us the correlation among two variables. So scatter plot is used to check the correlation among multiple variables. There is two variables. So here we will do scatter plot. So we can use pandas. On top of pandas, we can use this df.plot.scatter, and we have to pass here x value. So I'll say x is nothing but all electronics is S. This is X, and Y is nothing but it is high tech. So these are the two datas which we have, X and Y, and once we plot this, it will show us the data in scatter plot. So it just shows the data in scatter plot, that is when all electronics stock price was 2.0, that is the first one is around 2.0 here. Here it is showing like 2.0, okay, that is all electronics, that is 2, and this was around 5. So like that it just shows, like here it is like Y is nothing but 5, that is high tech stock price was 5. So like that it just shows the correlation among scatter plots. So we can see how they are related. It looks like little bit linear, but we will just measure this by covariance and the correlation. So now first to check the covariance. Now to find out the covariance among this, like first we will check with sample covariance, then we will check with population covariance. So sample covariance, we can use this np.cov, that is numpy.cov. Numpy has a function called as cov, which is used to check the covariance. We'll pass the data, that is all electronics is the data here, and the other data is nothing but high tech. So this is how we have to pass the variables. So we have two variables. We want to find out the covariance, that is all electronics and high tech. These are the two variables. So once we run this, it will give us the sample covariance. So it gives us the value as 8.75. This is the sample covariance of the data. So now here, how it shows, like this is the data we have to see actually. That is like the first data is nothing but the linear. This is the linear data, and this is the actual data. Like 2.5 is nothing but all electronics versus all electronics. So X with X, and this 40.7 is Y with Y. So this is just the variability or the variance within the data, and this 8.75 is nothing but the covariance among the data. We can find out the covariance, that is the population covariance, like by using a different method, that is COV function only, and here we can pass bias equals true. Like if we pass bias true, what will happen is it will just give us the population variance here. So it gives us 7. The variance now is 7. Okay, so this is the covariance, population covariance, that is 7. So if we look at the data what we calculated earlier, so we were also getting 7 as the covariance among all electronics and high tech. So this is a population covariance which we got, so which is exactly same here. Now we can also find the covariance using using this one, that is pandas. That is, if we write df dot cov, that is data frame covariance, on top of the data frame it will find out the covariance. So here if I run this, it just gives us the sample covariance, that is 8.75, like this. It also labels the data, so it is easier to see how the things are. So here we can see all electronics with high tech covariance is 8.75. All electronics with all electronics is 2.50. This is nothing but the variance itself. So if I say np dot var of I'll take the data as all electronics. So here it gives me 2.0. This is nothing but this is the same 2.0 here we are getting. Okay, so I'll just move it up. Okay, so here we are getting a uh, population variance. Okay, so same 2.0, that is for all electronics. Similarly, if we find out the variance for the other one, that is the other one is high tech, so it is 35.26. So same value we are getting. So this value is nothing but this value is high tech with high tech, so variance it will give. And this value is, this 7 is nothing but covariance among x and y, that is all electronic and high tech. So like this, so like this we can see here within the table. So that is all electronics and high tech, the covariance is 8.75. All electronic and all electronics is nothing but the variance itself. Similarly, here high tech with high tech here is nothing but the variance, but high tech with all electronics is again covariance. Like this we can measure. So this is how we can measure the covariance. But covariance value is like 8.75. That means there is a positive linear relationship. So we can see here from the graph also it looks like a positive linear relationship. But to what extent it is positive, like how positive it is, we can find out that by using np dot corrcoef function, and we can pass the data, that is all electronics and the other one is high tech. So now here it shows 0.86, means they are 86% linear, like from like -1 to +1 scale it will show the values. So this is what it shows. We can also get it like this, saying corr df dot corr using pandas also we can get it. So here it shows like all electronics with high tech is 0.867. This is the relationship. So it's like a very strong positive relationship we have within all electronics and high tech stock price. So when all electronics price is increasing, high tech stock price is also increasing in the same way, like 80% they are linear. So we can also say here, like with an 80%, like 86%, we can also predict the values of high tech stock price given the all electronic stock price, or all electronic stock price given the high tech stock price, like that. So this is how correlation we can implement in Python. So we just saw how to implement covariance and correlation. So within this session, what all we saw what is covariance. So to measure like two variables relation, like how they are related, we can use this covariance, and the value will be within -infinity to +infinity. And we can have positive covariance or negative covarience or no covariance. And like finding the covariance, we just saw how to find the covariance, like population covariance as well as sample covariance. Then we took an example and saw how to implement covariance. And then we looked into correlation, which is a technique which is a scaled version of covariance and extended version of covariance, we can say. So here it can also tell how strongly two variables are related, and the value of correlation will be within -1 to +1. And to measure the value of correlation will be -1 to +1, and value of covariance will be -infinity to +infinity. And to measure the correlation, we have this Pearson's correlation coefficient, which is nothing but covariance divided by standard deviation of the data. And then we looked into correlation values, like what kind of correlation can be there. It can be a positive correlation if you get a positive value of r, and it can be a negative correlation if you get the negative value of correlation coefficient, which is nothing but r. and no correlation if we get a value as 0. And the key difference between them, we just understood that like a change in scale can affect the covariance, but it will not affect the correlation. So that's where like covariance is not a unit free measure, while correlation is a unit free measure. So correlation also we understood that it's a better measure, as we can get the degree of association as well as the unit it is a unitless measure. So that's why it is one of the like best compared to covariance. So this is all about covariance and correlation. Okay, thank you.